Hello viewers, this lecture is based on the electromagnetic radiations. Now this is an important topic that is related to the radiation. The second topic, atomic structure, each and everything about that. Now let's first identify that what does a word electromagnetic basically comprises of. It is comprises of two types of radiation, that is first electrical one and second one is then magnetic one. In most of the experiments, like in the cathode rays, in the anode rays, in the gamma rays, in any type of the rays, we identify whether it has the weight or charge by this one. By electromagnetic waves, we identify the charge of any of the subject or any of the wave by simply passing it with within that rays or radiations. It simply get attracted towards the positive or negative terminal of that one charge. Just suppose that I do have a cathode rays. Now what I will do, simply I will place electrical resistor or capacitor, any electrical device. Now what will happen when this radiation will pass? It will simply get attracted towards the positive terminal. Why? Because we know that cathode ray has the negative charge, so it gets attracted towards the positive charge, and that's how we identify that it is a charge having the negativity. Apart from that, the magnetic field is usually used to identify the mass of the object. As a magnet do have poles, north pole and south pole, so simply anything that has a mass will attract it towards the north pole, and if it do not have any mass, it will simply pass. It will not get attracted to both of them. So that's how we identify the mass using the magnetic field. Now it is clear to you all why we do use magnetic word electromagnetic radiation, because it too comprises of charge as well as mass. But here one thing is that the word radiation is attached at the end. Now basically we do know that radiations are things that do not have mass, but it has a work of an electromagnetic harmful radiations, or we can also say that there is a wave that harms a normal screen or normal cells. So the basic electromagnetic nature is a form of energy that exhibits in the form of wave-like behavior or travels through the space. Now one thing that to be noticed is that visible light is a type of electromagnetic radiations. But apart from that, other examples of electromagnetic radiation includes visible light from the sun, microwaves, light or rays from the warm and cook of a food, x-rays that doctor do use, dentists use to examine the bones and the teeth, the waves that carries radiations of radio or television by which it are on or off, or it works with that. So these are all type of electromagnetic radiations which contains of both electric and magnetic properties, as well as it is in the form of the radiation that are being produced by different variations or different resources. So let's first examine that what do a proper waves do. So all waves can be described by several characteristics. Let me first remove this all so that I can write the characteristics. Now we know that any of the radiations are identified by simply passing it through the electric and magnetic field by which it gets attracted, and we know that it is the characteristic of this rays. For same as the radiations have some of the characteristics by which it can be studied. First of them is waves or frequency. First one is a frequency. A frequency of any of the wave can be a major factor of determining its speed, determining its velocity, determining its contraction, and all this. After that, second thing that comes in that is a lambda, that is denoted by the wavelength. So basically, wavelength is also another factor that tells us how many crust and trough do a normal waves do have. Now for specifying, we can determine different types of wavelength by different types of things like that. So these are two factors that can work for us to determine anything. Apart from that, there is a third factor too, and that is amplitude. Amplitude is directly related with the frequency of wavelength. Or we can also say that these all factors are related to each other because these all works combinedly to create a specific thing or a specific radiation or any kind of a specificity. Now let's study these three factors with respect of the normal electromagnetic spectrum, that is a proper variation of things or the waves that we do have and we have discovered till now. So there is a proper chart for it. Let's move on to that chart and I will tell you about the details on that chart. Now here you can see a work of all the things. Here you can see that there are specifying that this wavelength is specified with geomagnetic and sub-Elf resources, extremely low frequency, very low frequency, and then it comes with the term of the radio frequency spectrum, and then microwaves, and then infrared, ultraviolet, that is basically IV, and no, it's not IV, it's IR, and then UV. Now, have you noticed that world is way greater than IV, UV, and visible light? So basically, after that we do have X-rays and gamma cosmic rays. Now you can see you have examined that here it do have a compressed or longitudinal type of system, but basically these all waves are mostly transverse wave. But here you can examine that here from this region to this region at the side of this resources that are used in earth and subways, AC powers, CRT monitors, all these have a longitudinal wave. Now here this is specified as 30 kHz. Now here you can see that the wavelength and the amplitude all have a characteristics. By that we are able to hear what we are going to hear, the radiations, that EMF resource or the velocity, the current that we are currently using, these all are because of these waves. Apart from that, the wavelength decreases, and here till this region there is radio frequency spectrum. Most of the time the radio electromagnetic spectrum starts, oh my god, it starts from this region, from radio frequency. So most important part is this one. Radio frequency includes the frequency from 3 kHz to 3 gigahertz. Now here the radio frequency is equal to the speed of the light, but the thing is that it is only used for the transitions, like the radios that are not being able to be determined by normal naked eye, but they do have a important work because of the characteristics of electric and magnetic. When this wavelength and the frequency increases and wavelength decreases, the here is another thing that are known as microwave. Microwave is basically used to control the satellites. Apart from that, the basic infrared, ultraviolet, and visible light comes. Now these are produced by sunlight, we do know that. They do have different uses too, but we're going to discuss that later. Apart from that, you can see here the frequency increases, wavelength decreases, amplitude also increases. This works and pass with the speed of light. Now here the ionizing power is greater. It cannot be ionized. Likewise, we do use X-rays to determine our bones or do things like that. After that is gamma cosmic rays that are a most harmful rays in the world that can produce a severe harm to human beings. So basically, these are all the electromagnetic spectrum, and I hope that you get this. Thank you for watching.